And you ever just look up at the night sky and think, how in the world do we actually know all that stuff out there?
Mhm.
I mean, it's not like we can just, book a star cruiser for a weekend getaway to the Andromeda Galaxy, right?
Huh. No, not quite. It really makes you appreciate the ingenuity of the scientists.
Absolutely. So, in this deep dive, we're going to unpack the amazing toolkit that allows us to peer into the cosmos. We're talking about capturing the faint whispers of light from space, even the kinds our eyes can't even perceive, and the truly mind bending technology we've developed to essentially give ourselves superpowered cosmic senses.
Yeah, our sources for this exploration, they really detail the fundamental principles behind our ventures into space and the incredibly sophisticated instruments that make it all possible.
Our goal today is to really get a handle on the cleverness behind our cosmic observations, from the giant eyes we've planted right here on Earth to the spacecraft that are orbiting our world, and even those that have journeyed to the far reaches of our solar system.
Yeah.
Okay, let's dive in. First things first, light. It's the ultimate messenger from the universe, wouldn't you agree?
Without a doubt. I mean, light carries just a wealth of information about the objects that emit or reflect it. It basically paints a picture of the cosmos for us.
Exactly. And it's not just the pretty visible light that gives us those stunning nebula photos.
Yeah.
There's a whole spectrum of invisible light out there, isn't there? We're talking about infrared and radio waves, the sort of lower energy end of things.
Precisely. And then on the higher energy end, you've got ultraviolet, X-rays, gamma rays. And what's fascinating here is that different wavelengths of light, they interact with matter in different ways. So observing in these different parts of the energy spectrum, think of it as a continuous range of light. Each reveals different secrets.
Hmm?
It allows us to study different physical processes happening out there.
Right. Yeah.
For instance, infrared that can penetrate dust clouds to show us where stars are forming, maybe. While X-rays, they reveal incredibly energetic events like black holes gobbling up matter.
So it's like having a set of specialized eyes. Yeah. Each tuned to a different cosmic frequency, revealing a completely different view. Now, to actually grab all this light, whether we can see it or not, we've built some seriously impressive pieces of equipment, haven't we? Enter the telescope, our primary tool for extending our vision into the depths of space.
At its core, yeah, a telescope just amplifies our ability to see distant objects. It does that by collecting far more light than our eyes ever could. Whether it uses mirrors or lenses, the fundamental principle is to gather this light and focus it, making faraway objects appear larger, brighter. Now, there are two main types. Reflecting telescopes use mirrors, which, well, they allow for much larger light gathering surfaces. That's crucial for our great observatories. And then refracting telescopes use lenses.
And it's not just about making things a bit bigger in the viewfinder, is it? The sheer size of a telescope's light collecting area is what really makes the difference.
Absolutely.
It's like trying to catch more rain with a bigger bucket. The larger the surface, the more light you can capture from faint and distant objects.
Yeah,
That leads to much clearer, more detailed images.
exactly right. Most telescopes have a primary light gathering element, usually a large mirror, to collect and focus the incoming light. And then there's an eyepiece or maybe a detector to observe or record the focused image. When we talk about great observatories, we mean telescopes with primary mirrors exceeding 30 feet or 10 meters in diameter. Huge. These colossal instruments are typically housed in observatories situated on high mountaintops far away from city lights.
Yeah, that light pollution's a killer for stargazing.
It really is. Light pollution from urban areas scatters into the atmosphere, creates this background glow, makes it incredibly difficult to detect the faint light from distant stars and galaxies.
Talk about needing a serious permit to build those things.
Hmm.
And the power they wield is just mind-boggling. I remember reading that the Keck telescopes in Hawaii could spot a candle flickering on the moon. That just seems impossible.
It's an incredible testament to their sensitivity, yeah. It really is. And that level of sensitivity allows us to detect the faint light from the very earliest stars in the universe. Gives us a glimpse into the very beginnings of cosmic time. The Very Large Telescope, the VLT down in Chile. It can see objects billions of times fainter than what our unaided eyes can perceive.
Billions. Wow.
Think about that, capturing light that has traveled across the universe for billions of years.
Seriously puts my attempts at astrophotography with my phone to shame. Okay, so we've got these incredible light collectors on the ground. But sometimes even the clearest mountain air isn't good enough, right? That's where the genius idea of putting telescopes in space comes into play.
Precisely. Earth's atmosphere, I mean, it's vital for us, obviously, but it unfortunately also distorts and absorbs certain wavelengths of light coming from space. By launching telescopes above the atmosphere, we eliminate this blurring, this absorption. We gain a significantly sharper and clearer view of the cosmos across the entire electromagnetic spectrum.
And just like our Earth-based telescopes, different space telescopes are designed to study different types of light, right? You wouldn't use a telescope designed to detect super hot X-rays to study, like, the formation of cool, dusty star nurseries.
Exactly. Telescopes like Chandra, which observes in X-rays, they're crucial for studying extremely energetic phenomena. Think black holes, remnants of exploded stars, supernovae. On the other hand, the James Webb Space Telescope, which primarily observes in the infrared, well, that can peer through those obscuring clouds of dust and gas. It can reveal the birth of new stars and planets.
And we absolutely have to mention the Hubble Space Telescope. It's become such an iconic symbol of scientific discovery, hasn't it?
Oh, absolutely. The Hubble Space Telescope, launched way back in 1990, is arguably the most successful telescope ever built. Its decades of observations have just revolutionized our understanding of the universe, and it's given us some of the most breathtaking astronomical images ever captured. It's orbiting about 370 miles above Earth, size of a bus, roughly, weighs around 24,500 pounds.
And it wasn't just a set it and forget it mission, was it? Astronauts actually went up there multiple times to fix it and even install new, more advanced equipment. Talk about a high-stakes service call.
Those servicing missions were absolutely critical to Hubble's longevity and its continued scientific output.
Yeah,
They allowed for upgrades to its optics, installation of cutting-edge instruments.
yeah.
It significantly extended its operational life and its ability to make just groundbreaking discoveries.
Okay, so we're using light to study these incredibly distant stars and galaxies. But what about the celestial bodies closer to home? Like the planets and moons in our own solar system. We can't exactly zoom in with a giant telescope from Earth and see if there's traffic on Mars.
No. That's where spacecraft and planetary missions become essential. While the vast distances to stars, measured in light years, you know, the distance light travels in 1 year, make interstellar travel incredibly challenging with current tech. The planets and moons within our solar system are within reach of robotic spacecraft.
And we've sent probes and orbiters to pretty much every corner of our solar system, haven't we? Every single planet has had a visitor, and we've even managed to land probes on some fascinating worlds like Venus, Mars, Titan, not to mention those encounters with asteroids and comets.
It's an incredible achievement of engineering, really, and a testament to our relentless drive to explore. However, it's important to remember that the moon, well, it remains the only extraterrestrial body that humans have ever set foot on. That was during the Apollo missions between 1969 and 1972.
Those Apollo missions were truly historic. Now, some of these robotic spacecraft missions have been going on for decades, and they've sent back some truly mind-blowing information. I'm thinking about Voyager 1,
Ugh.
which has actually journeyed beyond the edge of our solar system. That's just,
Yeah.
wow.
Voyager 1, launched way back in 77, is an astonishing example of endurance and scientific return. Just amazing. It's now over 100 times the distance between the Earth and the Sun. Its twin, Pioneer 11, launched a couple of years earlier, it even carries those iconic plaques, with drawings of humans and our location in the galaxy, a message in a cosmic bottle, just in case it's ever found by another civilization.
Talk about sending a wish you were here postcard to the cosmos.
Mhm.
And Mars has been a real focus for exploration, hasn't it? We've got orbiters circling the planet, landers touching down, and those amazing rovers trundling across the Martian surface.
Mars has indeed been a prime target, mostly due to its relative proximity and the evidence suggesting it may have once been more Earth-like. Missions like the Curiosity and Perseverance rovers, they're actively studying the Martian geology, searching for signs of past or present water, and even looking for potential biosignatures evidence of life. The Opportunity rover, which operated for many, many years, provided invaluable data about the planet's history and the presence of liquid water in its past.
And who can forget the Huygens lander touching down on Titan, Saturn's largest moon, and discovering lakes and rivers made of liquid hydrocarbons? It sounds like something straight out of science fiction.
The Huygens landing on Titan was truly remarkable, just an incredible feat. The discovery of these liquid hydrocarbon features, it completely changed our understanding of what constitutes a habitable environment, really. It suggests that life might exist in forms we haven't even imagined, in places with radically different chemistry than Earth.
So we've come so far in our exploration of space, but what does the future hold? Are we on the verge of interstellar travel, or are there still major hurdles?
Well, interstellar travel with current technology, it remains a significant challenge. The immense distances involved are just staggering, but scientists are constantly working on developing more efficient propulsion systems and advanced robotics to push the boundaries of our exploration capabilities.
I know there's been a lot of buzz about sending humans to Mars. That sounds incredibly ambitious, though. Just the sheer travel time, not to mention the lack of a breathable atmosphere and the constant radiation.
Yeah.
It's a bit more involved with packing for a road trip, yeah.
Oh, definitely. A crewed mission to Mars presents immense technological and logistical hurdles. Huge. We're talking about multi-year journeys. The need for closed-loop life support systems, recycling air and water, robust shielding against harmful radiation, and even strategies for growing food in space to sustain a crew for that long. Pre-deploying supplies and potentially establishing underground habitats or greenhouses are all being considered. It's incredibly complex.
It makes sense that the moon is being looked at as a sort of training ground for Mars missions, doesn't it?
Exactly.
Similar gravitational pull, no atmosphere to speak of, but at least it's only a 3-day trip if things go sideways.
The moon offers a really valuable testing ground for technologies and protocols needed for longer duration missions, like a trip to Mars. It allows us to practice living and working in a reduced gravity environment, to refine our ability to operate independently of Earth's resources, all within a relatively short travel time. It's a good stepping stone.
And beyond Mars, there are those intriguing icy moons of Jupiter and Saturn, like Europa and Enceladus. Scientists are really excited about those because of the potential for vast underground oceans. The thought of finding even simple microbial life in those hidden oceans, that's just a mind-blowing possibility.
It really is. These underground oceans could potentially be heated by tidal forces, gravitational forces from the giant planets, causing flexing and heating inside the moons. That makes them potentially habitable environments. It's a key area for future exploration.
Okay, now for a quick detour into some fascinating space facts. I've always wondered, can you actually see the Great Wall of China from space?
That's a popular misconception. While the larger pyramids at Giza are visible from the ISS, the International Space Station, with binoculars or a good camera, the Great Wall of China is generally too narrow and it sort of blends in with the surrounding terrain. You can't easily see it from orbit with the naked eye.
Right.
And certainly not from the moon. No way.
Okay. Why is it that astronauts' spacesuits are almost always bright white? Is it just a fashion statement for interstellar travel?
Huh. Not quite. The primary reason for the white color is actually thermal regulation. White surfaces are highly reflective, meaning they reflect a large percentage of the sunlight that hits them. This is crucial in the vacuum of space, where there's no atmosphere to dissipate heat. Prevents astronauts from overheating from intense solar radiation.
Makes sense.
Plus, the white also provides good visibility against the blackness of space, which is important for safety during spacewalks.
Space junk. It sounds like something out of a low-budget sci-fi movie. How much of that stuff is actually orbiting our planet?
Yeah, the problem of orbital debris, or space junk, it's a growing concern, seriously. There are hundreds of thousands of pieces of debris in Earth orbit, ranging from defunct satellites and rocket stages down to small fragments, even tools lost during spacewalks. This debris poses a significant collision risk to operational satellites and the ISS.
Wow. Okay, I remember hearing about the Galileo probe meeting an explosive end on Jupiter. What was the story behind that?
Right, so after years of successfully studying Jupiter and its moons, the Galileo mission was intentionally terminated to prevent any possibility of the probe contaminating Jupiter's moon Europa, which, as we mentioned, might have a subsurface ocean.
Potential life, yeah.
Exactly. Scientists directed Galileo to plunge into Jupiter's atmosphere. The immense pressure and heat of Jupiter's atmosphere just crushed and vaporized the probe. It had also reached the end of its operational life, was running out of fuel anyway.
I've heard that spacecraft can actually use the gravity of planets to speed up. That sounds a bit like a cosmic free ride. How does that work?
It's a clever maneuver, yeah. Called a gravity assist or sometimes a slingshot effect. Spacecraft are carefully flown close to a planet, using the planet's gravitational pull to accelerate the spacecraft and redirect its trajectory. It's like borrowing some of the planet's orbital momentum to gain speed and save a lot of fuel on long interplanetary journeys.
Could a regular Boeing 747 just fly to the moon if it had a big enough gas tank? I mean, theoretically.
Unfortunately, not even in theory. Nope. Airplanes rely on air for two critical functions, right? To generate lift with their wings and to burn fuel in their jet engines. Space is a vacuum. There's no air for either of those things to happen.
Right. No air.
Even if a 747 somehow made it into space, its engines wouldn't work, it couldn't generate lift. Plus, even traveling at 747 speeds, it would take weeks to reach the moon. Not practical.
Okay. Okay. What about alien spacecraft? Have we ever actually found definitive proof of one landing here on Earth? You know, the whole UFO phenomenon?
Well, despite countless anecdotal reports and unidentified flying objects, there has been no scientifically verified evidence of an alien spacecraft landing on Earth. None. The vast majority of UFO sightings can usually be explained by things like misidentified aircraft, natural atmospheric phenomena, weather balloons, or even optical illusions.
I saw something about a mission that's going to get incredibly close to the sun. That sounds like a recipe for a solar barbecue.
Huh. Yeah, the Parker Solar Probe mission is designed to do just that, get remarkably close to the sun, actually within the orbit of Mercury. It's equipped with this really sophisticated heat shield made of carbon composite material that can withstand the extreme temperatures and intense radiation in that environment. It lets us study the sun's corona and solar wind in unprecedented detail.
Rocket engines must generate absolutely insane amounts of heat. I can't even fathom it.
Oh, the temperatures inside a rocket engine during launch are truly extreme. Unbelievable. For example, the main engines of the space shuttle could reach temperatures of around 6,000 degrees Fahrenheit. They burn through millions of pounds of fuel in just a few minutes to generate the thrust needed to escape Earth's gravity.
Here's a thought. Will the footprints that the Apollo astronauts left on the moon still be there millions of years from now?
Essentially, yes. Because the moon has virtually no atmosphere, there's no wind or water erosion to erase those footprints. Nothing to disturb them. They will likely remain undisturbed for millions of years, a lasting testament to humanity's first steps on another world. Pretty cool.
Okay, to wrap things up with some cosmic bragging rights, give me 3 of the most impressive spacecraft facts.
All right, 3 highlights. Let's see. First, the tallest rocket ever constructed was the Saturn V, the colossal rocket that propelled the Apollo missions to the moon. It stood taller than a 30-story building.
Wow.
Second, the fastest spacecraft ever built is the New Horizons probe. It zipped past Pluto at an astonishing speed of over 36,000 miles per hour.
Incredible.
And finally, uh, the most distant object ever directly interacted with by a spacecraft, that would be Titan, thanks to the Huygens lander.
From incredibly sensitive telescopes, allowing us to peer across billions of light years, to robotic explorers sending back data from alien worlds, it's truly astounding how our insatiable curiosity, coupled with incredible technological innovation, has allowed us to unravel so many of the universe's secrets.
Absolutely. Our understanding of the cosmos is just this constantly evolving story, isn't it? Driven by the ingenuity of scientists and engineers who continue to push the boundaries of what we thought was possible.
So the next time you look up at the night sky, maybe take a moment to appreciate the incredible journey of discovery that has allowed us to know what we know. And on that note, considering the vastness of space and the ever-evolving technology we use to explore it, what future discoveries do you think will fundamentally change our understanding of our place in the cosmos? What unseen phenomena might we be on the verge of detecting? It's definitely something to ponder. Thanks for taking this deep dive with us.